Welcome to today's lessons on vapor pressure. Okay, so vapor pressure is the pressure exerted by vapors above a liquid in dynamic equilibrium. Well, what is dynamic equilibrium? Well, we know equilibrium, something equal, if we look at the prefix, so being the same, occurs when two opposite processes occur at the same rate. So we're talking here about evaporation and condensation when we look at these vapor pressure graphs. And what does vapor pressure depend on? Well, it depends on two things, temperature and strength of IMF. So what is IMF? Intermolecular forces is what IMF stands for. So you have temperature and intermolecular forces. Another vocab word you need to know and identify is volatile. Refers to how easily a fluid evaporates. So high vapor pressure. Well, if we look at the water and alcohol over here, we have two things to compare. We can see water condenses much bigger arrow and evaporates with a much smaller arrow because water has high intermolecular forces. Alcohol does not, and we can see that it wants to be a gas, and it goes gas much easier than it does become a liquid and condensing. So alcohol is a volatile, much more volatile than water. Okay. The next thing we need to look at is when we look at vapor pressures, atmospheric pressure or pressure from gases above, right? So remember, atmospheric pressure is about pressing down from the atmosphere, and it presses down. So think you can imagine your hand over a pot of water boiling, right? And if you're pressing, does the gas that's the liquid that's trying to turn to gas, is everywhere to go if something's pressing down on it? No, but as we've already talked about, as you go up in altitude, there's less air molecules there, and so there's less atmospheric pressure. So one of the things, I moved to Colorado, and I was really excited because my water for my macaroni and cheese I wanted to make boiled a lot quicker than when I was here in Texas. And I was super excited thinking, oh, faster macaroni and cheese. But the problem is it boils at a lower temperature. And so it took actually just as long as cook because the noodles still need the same amount of energy to cook, but just because it boiled at a lower temperature, so it took the same amount of time. Okay, so we can see here that when we talk about pressure pressing down, as pressure is higher, we have the highest boiling point. If so, we're looking at water here. So at 1,000 millibars, which is about sea level, it's about 100 degrees Celsius. And as we go up in elevation, pressure drops, and we see that the boiling point is now 92 degrees. It's cooler, right? So that's why the macaroni and cheese still took the longest time, even though it's boiling. So, looking at a graph. This is a vapor pressure graph, and we can see here that we've added several different lines, substances, right? Each of these lines is a different substance. And what this line actually is if you think back to the phase change graph, there was a line for condensation vaporization, right? It separated liquids on the left from the gas on the right. Well, these are actually just those lines. If we were to take this focus on what we're doing is zooming in and focusing on that vaporization condensation line, separating gas from liquid. So if we look here, we can see everything to the left of the line. If it's this pressure and this temperature, that substance is a liquid. If it's to the right, if the pressure and temperature is to the right of the line, that substance is a gas. And we just add a whole bunch of substance over here, those condensation vapor lines. So when we look here, let's take a look at now your practice. And we're going to, if the pressure and the temperature are to the left, it is a liquid. If it's to the right, it's a gas. So if we want to highlight, and I'll highlight that, and that means substances are liquid when the point is to the left. Okay? What is the normal boiling point of substance A? Remember, normal from the phase change is at sea level pressure, and here that's this millimeters of mercury, so here it's 760. and A would be right there. So we're talking about 120. Okay, just like reading a phase change graph. The key here is something like this. So if I say the temperature right now is 160 degrees Celsius and 600 milligrams of mercury. So when we take a look at that, right, we're talking right here, we draw a line going across to 160, and we're going to go down. So we're talking about this point right there, right? So when we're looking at each individual something, we need to compare where that line is, okay? So if we're looking at substance A, we look at that point and we go, oh, that temperature and pressure is to the right of the condensation. So what phase would this be? Just like the phase change graph. If it's to the right of that line, it's a gas. Okay. A and B, we can see that it's also to the right. So substance B would be a gas at that temperature and pressure. C and D, we can see that they're to the left. So each of those substances at 600 milligrams of mercury and 160 degrees Celsius would both be liquids. Okay, and that's how you read the graph. It's just kind of a zoomed in. We're only looking at a specific part of the phase graph. Okay. So using this and going forward, so which substance is the most volatile? Well, which one is easier to become a gas? Where's the most gas? It's going to be A, right? A is the most volatile, D being the least volatile. Okay, so expect questions coming up on that. So what is the external pressure for B to boil at 313 K degrees? So if you look, that's way off the graph. It would be, whew, that's a high pressure, right? We're talking B, that's going to be way off. Oh, converting to Kelvin. See, forgot to do that. 40 degrees, sorry. So 40 degrees right here. And we're looking at B. And what would the pressure be to boil at that? Well, it'd only be, it would have to be 200 millimeters of mercury. Okay, so which substance do you think has the highest critical temperature? Meaning, which one will can get hotter before it becomes a gas? Well, that would be D, right? Because it's right here. It takes a lot of temperature for it to boil, especially at normal temperature. It's 240 degrees Celsius to boil there. So that's kind of how you read. Practice on the back and come questions with the teacher. And have a good rest of your day.